Hello everybody, in today's video we're going to be going over the basics of the periodic table. So some things that we're going to be covering throughout this video is first, who Mendeleev is. Second, we'll cover what Mendeleev did and what he's famous for. Third, we're going to cover over the periodic law. Then we'll cover what rows and periods are. We'll also cover what the periodic families are, for example, alkali metals, alkaline earth metals, and such more. And then we'll cover over element information. And finally, we're going to be going over a Python code for getting element information. So this is basically just the scope of what we're going to be covering throughout this video. So let's get started with who Mendeleev is. So first of all, Mendeleev was a Russian chemist who was the architect of the periodic table. So what did Mendeleev do? So when Mendeleev arranged the elements in order of increasing atomic mass, he found that the properties of the elements repeated at definite or periodic intervals. And this pattern of arrangement that Mendeleev discovered became known as the periodic table. So technically you can say that Mendeleev was the starter of the periodic table. So what was Mendeleev famous for? So Mendeleev is most famous for leaving gaps for elements that were yet to be discovered. So here's just a table of how Mendeleev's periodic table looked like. So as you can see in the picture, you can see that there's many left out gaps where there's like no elements there. And you can see that they're all going in increasing atomic mass. So starting at just 7, then it increases all the way to 240. And in between, you can see that there's many gaps so for new elements to be discovered. So this is basically just how Mendeleev's periodic table looked like and what he basically did. So also in Mendeleev's periodic table, he said that all elements have not been discovered yet. So instead, Mendeleev gave them another name. So for example, an element that was one step away from aluminium, he would call it aluminium. And he did this because he knew that the element would be similar to aluminium. So if we remember back to the periodic table of Mendeleev, so you know all the gaps there, so basically if it was one behind aluminium, then he would just call it aluminium because he knew that the properties would be similar to aluminium but it wouldn't be the exact same. So that's basically what Mendeleev did. And so that's also why he was famous, so that's what he did in his periodic table. And later on, the element place of 101 was named in the honor of Mendeleev in 1963. So the element number 101 was named after him, called Mendeleevium, and that was in honor for all of his successful work. So that basically wraps up everything about Mendeleev. And next we're going to be covering over the periodic law. So the periodic law states that the physical and chemical properties of an element repeat in regular patterns which they are arranged in order of atomic number. So we're going to cover more about this later on, so let's just go on to the next slide. So now we're going to be talking about the modern periodic table. So we know that the periodic table consists of groups and periods. So periods are basically just the horizontal rows, and if you look in the picture here, there are 7 periods, 1 to 7, and they're basically just the horizontal rows that go across. So elements of each row have the same number of energy shells, and also the period number of an element signifies the highest energy level in electron that the element may occupy. So that's basically what periods are, just the horizontal rows, and each of the elements have the same energy levels, which are basically the shells. And now let's go over what groups are. So groups are the vertical columns, and if you look in the picture here, there are 18 groups in total in the periodic table. And each column has the same number of electrons in the outermost shell, and these are called valence electrons. And elements in the same family also have similar properties. So basically the groups are the vertical columns and the periods are the horizontal, and there are 18 groups and 7 periods. So that's basically just a little bit about the modern periodic table, about the groups and columns. And now we're going to talk more about the families. So there are a few different families in the periodic table, and the first one we have is alkali metals, and those are basically just group 1. So if you look in group 1 from all the way to the top to the bottom, those are all alkali metals. And some properties of alkali metals are that they are soft, they're silvery, and they're extremely reactive. So for example, all alkali metals will react with water. And also you will not be able to find these alkali metals in their pure state anywhere in nature. So for example, you're not going to be able to find sodium laying down outside anywhere. It can only be found in nature when it's in combination with other elements. For example, like salt, that's where you can find sodium connected with. But otherwise, you're not going to be able to find any of these alkali metals out there in nature just by itself. So that's basically just alkali metals, so they're group number 1. And second, we're going to cover over the alkaline earth metals. So alkaline earth metals are just group 2. So right after the alkali metals, all the ones here are alkaline metals, alkaline earth metals. And some properties of alkaline earth metals are that they are extremely reactive, but they're not as reactive as group 1. So the alkali metals are still more reactive than these alkaline earth metals. And you still won't be able to find these metals in pure state anywhere in nature either. And just like alkali metals, they are only found in nature in combination with other elements. So alkaline earth metals are the second groups, and that's basically some of the properties of them. So next we're going to cover over transition metals, and transition metals are found from groups 3 to 12. So all this space here is about transition metals. And so properties of transition metals are that they are typically metals with high melting points. They have a variety of oxidation states. They usually combine to form colored compounds, and they are frequently paramagnetic. So transition metals are basically the ones that cover the most from groups 3 to 12, and those are just some properties of the metals here. So now let's cover over metalloids, and usually the metalloids are found from the groups 13 to 17. So all of this would be consisted of metalloids. So basically metalloids are found in a zigzag line. So if you look in this picture here, you can see that these are all metalloids, the ones that go in a zigzag line from the groups of 13 to 17. So just these on the zigzag line would be the metalloids. And so the properties of metalloids are in between metals and non-metals, which we will cover later on in this video. So that's basically just what metalloids are. And now we're going to cover over halogens. So halogens are group number 17 here. So all of these that go down here, those are halogens. And some properties of halogens are that they are very reactive non-metals, and they usually like to go with alkali metals. And another property is that they are very colorful and they're very corrosive. And they have 7 valence electrons in their outermost shell, and they are all really toxic. So that's just a little bit about the halogens and their group number 17. And for our final group, we have noble gases, and they are group 18. So some properties of noble gases are that they are colorless gases, and they are very unreactive because their outermost shell is full. So that's basically just a little bit about noble gases. They're number 18, and they're really highly unreactive. So that's basically all of our families that we're going to be covering for this periodic table. And now we're going to be covering over what metals are and the properties of metals. So metals are usually found in general from groups 3 to 12, and properties of some metals are that they are solid at room temperature, except for one, which is mercury, which is liquid at room temperature. So all metals are always solid at room temperature, except for mercury, which sits at a liquid at room temperature. And metals are also really malleable, which means that you can form them into different shapes. And they are also workable, which means that they are not brittle. So metals are not brittle at all, and they're really malleable. And metals are also really ductile, which means that you can draw them into thin wire, which also means that you can draw them into wires. And metals are also really good conductors of heat and electricity. So that's just some properties of what metals are. And for non-metals, is basically just the opposite of what metals are. So whatever the properties we named for the metals, the non-metals will have exactly the opposite. So that's basically what metals and non-metals are. And finally we have the metalloids. So metalloids are the in-between of metals and non-metals. So basically they consist of some metal properties and some non-metal properties. Since on the staircase some of them will consist of metals and some of them will be non-metals, so that's why metalloids are basically just in between both of the non-metal and metal properties. So that's basically the properties of metalloids. And now we're going to be covering over what the element information is. So if we look here, we can see that there's an element's atomic number, and this should be throughout everything so we know what number it is. There's also the element's symbol, the element's name, the atomic weight of the element, and sometimes you might also see the melting point, the density, and the boiling point, and some other things, but usually the typical 4 that you will see is the atomic number, the symbol, the name, and the atomic weight. So those are the 4 most things that you always see. So that's basically what the element information is. And that basically wraps up the first part of this video, which is just talking a little bit about the basics of the periodic table. And now we're going to be going over some Python code that will help us to gather elements information. So just for a recap for what we're going to be doing with our Python code, we're basically just going to be gathering some information for a few different elements. For example, we'll use our code to figure out an element's name, an element's atomic number, an element's density, and more. And also, if you want to try out this code for yourself, I already have an installation guide for the step-by-step process in order to get this Python application. So I'll link that video in the description below for you guys to check that out as well. And so let's get started with our code. So first, on the top here, we're going to be importing our element information from Mendeleev, and this is already, I explained how to do this in our previous video, so make sure to check that out if you want to understand what this is saying. So second, here we're going to be choosing our elements. So for example, here I chose SI, which stands for silicon. So basically we already have a database here for this Python code. There's a database that has all the information for every single element. And basically what happens here is that you put the element symbol here, which is SI, and then you just assign a variable, for example SI or whatever you want to put it, and then it will basically have all the information for silicon. So here we're basically just putting SI is equal to all the element information for silicon. And then here we're going to be printing out an element's name, so we're going to be printing out SI's name, and basically this should print out silicon, and then we're going to be printing out silicon's atomic number. Then here we're going to be printing out silicon's atomic weight, then we're going to be printing out silicon's density, and we're going to be also printing out silicon's discovery year and silicon's discovery location. And there's also many more different things that you can do with this, and I'll show you that in a little bit. But for now, let's just run this and see our results. So if we run this, let's see if we get all these values back. So here, once the code is done running, we can see that it did print out silicon's name first, then it printed out the atomic number for silicon, then the atomic weight, then the density, then the discovery year, and where it was discovered. So we can see that this code does work, and just for more verification, let's try a different element. And for example, let's just try iron, which is Fe. So we're just going to replace this with Fe. So Fe is equal to the element Fe, so this should give us all the information for iron. And if we change all this to Fe as well, then we should be able to get the same information just for iron. So let's just run this and see if we get the results. So here it got printed out, and here we can see that it's printing out the name, the atomic number, the atomic weight, and the density. So that's alright, and basically it does print out, and you can change it for any single element that you want here. So basically if you want to choose a different element, all you do is change the symbol here from Fe to any other element that you want, and then just change this variable and make sure to replace these as well. And basically you can also do many more different things. So these are just a few different things that we can print out. For example, we just printed out the atomic number, the weight, the name, the density, but there's many more different things that you're able to print out, and some more different things that you're able to print out are over here. So if I zoom in a little bit, here you can see you can print out all these different things for any different element. So you can print out an element's atomic radius, the volume, the block. So basically everything that is on this you're going to be able to print out. And once again, this PDF will be linked in the description of our previous video, so if you want to check that out, then this will be there as well. And that's basically it for the second part of this video, where we found out the elements information. So that's basically it for this video, so thank you all so much for watching, and we'll see you guys in our next video.